Look up at the night sky. What do you see? Stars, planets, galaxies. A breathtaking cosmic tapestry woven from light. But what if I told you that everything you see is just a tiny fraction of what's really out there? What if the vast majority of the universe is invisible? A hidden realm of substance that governs the cosmos, yet emits no light, no heat, no signal of any kind that our instruments can directly detect. This isn't science fiction. This is the chilling truth of our reality. The universe is haunted by a ghost, an immense unseen presence we call dark matter. Our cosmic ghost story begins in the 1930s. It begins with a brilliant and famously cantankerous astronomer named Fritz Zwicky. He was studying the Coma Cluster, a cosmic metropolis with over 1,000 galaxies, located about 320 million light-years from Earth. He measured how fast the galaxies on the outskirts were moving, using the Doppler effect to calculate their velocities. What he found was astonishing. The galaxies were moving at incredible speeds, far too fast to be held by visible matter. Based on all the visible light, there wasn't nearly enough gravitational glue to keep the Coma Cluster from flying apart. The galaxies were like children on a merry-go-round spinning out of control. Zwicky realized something unseen must be holding it together. He called it dunkle materie, dark matter. For decades, his observation was treated as an anomaly, too radical for many. The case went cold for a few decades, until the 1970s when Vera Rubin entered the scene. She examined individual spiral galaxies, including our own. With Kent Ford's sensitive spectrographs, they measured star speeds at different distances. Newton says inner stars should move fast and outer stars much slower, but Rubin found the outer stars move just as fast as inner ones, a flat rotation curve. The only explanation: galaxies sit inside vast spherical halos of invisible mass, dark matter. That invisible halo contains the bulk of a galaxy's mass. This was happening in our own galactic neighborhood. Einstein taught us mass warp spacetime. That warp bends light. Gravitational lensing distorts background galaxies into arcs and multiple images. Measurements of that distortion show more mass than all visible stars and gas combined. The evidence extends beyond galaxies and clusters. It's written into the very fabric of the cosmos, the cosmic web. The cosmic microwave background preserves the primordial blueprint, tiny fluctuations that seeded structure. At 380,000 years, the universe became transparent and left us its faint afterglow. Simulations with only ordinary matter produce a too smooth universe. Add cold dark matter and filaments form early, providing scaffolding for galaxies. Ordinary matter falls into those wells, forming stars, planets, and ultimately life. Dark matter is not passive. It's the universe's architect. Without it, no beautiful spirals, no majestic clusters, no filaments. Our existence is a direct consequence of dark matter's gravitational work over billions of years. The first guess: it's just ordinary matter we can't see. Black holes, neutron stars, dim brown dwarfs, machos. Surveys monitored millions of stars for tiny micro-lensing events. They found some machos, but nowhere near enough to explain the missing mass. Big Bang nucleosynthesis limits the amount of baryonic matter to about 5% of the universe. Attention turned to new particles outside the standard model. Physicists proposed WIMPs, weakly interacting massive particles. The hunt went deep underground to shield detectors from cosmic rays. Experiments like LUX Zeppelin and Xenont used giant vats of liquid xenon to catch a tiny flash. So far, after years of searching, they have found nothing conclusive. The WIMP remains elusive. The failure to detect WIMPs has opened new doors. Perhaps dark matter is not one particle but a whole dark sector. One leading candidate is the axion, a feather-light particle. Axion searches are like tuning a radio. ADMEX uses strong magnets and cavities to convert axions to photons. They listen for a whisper from the dark. Alternatively, perhaps gravity itself needs tweaking. Mond proposes changes on galactic scales. Mond can explain rotation curves but struggles with lensing and the CMB. Dark matter is about 5 times ordinary matter, a puzzling cosmic coincidence. Why should a ghostly phantom and luminous matter exist in such comparable amounts? This may hint at a deeper connection between the visible and dark sectors, a clue we have yet to read. Today, on August 30th, 2025, we stand at a fascinating crossroads. We are more certain than ever that dark matter exists. The evidence, spinning galaxies, warped spacetime, the cosmic web, and the CMB, all point to it. We know it has shaped our universe, yet we know almost nothing about what it is. From deep underground detectors to next-generation telescopes, to the Vera C. Rubin Observatory mapping the sky in unprecedented detail. Particle colliders like the LHC smash protons hoping to create and catch dark matter in the lab. Solving dark matter would require new physics, a revolution on par with Copernicus, Newton, or Einstein. It would reveal 85% of the matter in the universe and a deeper layer of reality. It is an invitation to a new generation of scientists, engineers, and thinkers.